Hi everyone, good morning or good afternoon, depending on what time you watch this video. Welcome to week 8 of distance learning. We've got 3 weeks left before we call it kind of quits on this year, and I'm sure you are all very happy to hear that. And I'm looking forward to it too. I think the last week of school, so before the 16th, whatever week that is, even though we'll have school the 8th through the 12th of June. Even though we've got school that week, it's basically going to be just kind of like a makeup week because these days were supposed to be half days anyway. Um, so I think that we've only got 3 weeks left, and I'm very happy about that. Today, in today's lesson, we're going to look at some exponent properties, and we're just going to specifically focus on 2 of them. And then I might continue this next week as well. For this lesson, I'm going to be using this Cami app. I know a lot of people had problems with it last week. I didn't realize that you needed to install this Chrome extension. I'll post another link to it this week so that if you want to follow along in here, you can, but you don't have to. And I think I'll post some problems just in IXL this week, so you can do them on the computer. Make it easy, right? Make it easy for you. But if you want to follow along, go to this Cami extension, and I'll be using my little stylus here to do some work here. So I go to my text box, or maybe I'll just draw. Yeah, I'll just draw. Let's see. I'm going to draw in. Do I want blue, pink? Let's go pink. So let's see. I'm going to draw in here. So I'm going to write my name. Let's see if this works. Perfect. Good enough. But yeah, so we're going to talk about some exponent properties. So we're going to take the definition of what an exponent is and break it down and learn some properties. Properties are basically, sometimes they're just called rules. They're kind of like ways to make things simpler, so or shortcuts. You could think of them as shortcuts to rewriting exponents. Rules or shortcuts. I'm going to try to keep this video short because I know last week I posted like 3 videos, and I'm sure very few people watched all 3 of them. So let's go ahead here. We're going to talk about. Well, first, let's look at this. So let's expand the following expression. So what does expand mean? It means let's rewrite these exponents in like their most basic definition of what an exponent is. Remember, an exponent means repeated multiplication, right? So what we're going to do is we're going to rewrite these as repeated multiplication, expand it out. So for example, 5 to the third, what does that equal to? If we were going to expand that out, that's 5 times 5 times 5, right? 3 times. And that's what this exponent means, is that we write this exponent here, right? This power means that that's how many times we write this. It's three times. Right, so that's the basic definition of an exponent. Okay, so fair enough. What about x to the power of 7? How would we expand that out? Well, we could write it as x, right? That's our base. Remember, 5 here is the base. So that's what we were multiplying repeatedly. Here, x is the base, so we're going to multiply x by itself 7 times, right? X times x times x times x. And you might think, okay, 1, 2, 3, 4, 5, 6. Let me add 1 to the front. 7. Right? Okay, so yeah, I know what an exponent means. And even if we have a variable like x as the base, it means that's how many times we're going to write that base out. We're going to multiply it by itself. What about, so we have to remember what 5yz means, right? That means 5 times y times z. We can kind of separate it up and break it up, right? Because if there's nothing in between the two numbers or variables, right, it always means multiplication. And we're raising all of that to the third power, right? So there's the power. It's the third power. What does that mean? That means that we're going to multiply all of this stuff by itself 3 times. So that times times itself again, 5 times y times z. I'm going to have to move this one down a little bit, that's fine. Times 5 times y times z. Okay, we'll come back to this later. I'm just trying to expand everything out right now. And then this one, last but not least, I'll throw down here somewhere. Okay, x to the third raised to the power of 2. That's interesting. That's because, what makes this interesting? We've got x to a power to another power. Okay, so let's see. Let's expand that out. Well, x to the third power means x times x times x, right? And then we're taking that. I should have put these like maybe in parentheses. Before. So x to the third power is x times x times x, and then we're raising that to the power of 2. That means, maybe I'll do this in the other color here, this power of 2 means we're going to multiply it by itself 2 times. So here's another x times x times x. So we can expand this out. And hopefully we'll gain a little bit of understanding here by the end. Okay, now, so that's expanding, right? Expanding means write it all out as like repeated multiplication. Maybe I should write that somewhere. Write as repeated multiplication. That's what expanding means. Okay. What does it mean to simplify? Well, that means to do the opposite. Rather than writing it all out, we're going to take a big expanded thing and we're going to kind of condense it into a single exponent. That's what that means. So, can we write these as a single exponent? So these two things are kind of opposites of each other, expanding and simplifying. How would we simplify 4 times 4 times 4 times 4 times 4 times blah, blah, blah. Think about that for a second, right? I don't mind pause screen up, it's okay. But well, how could you write that as a single exponent? Well, you could write it as 4, that's the base, that's what we're multiplying itself by. How many times? To what power? To the power of 1, 2, 3, 4, 5, 6, right? To the power of 6. How about this one? How could we rewrite 6 times 6 times 6 times 6 times x times x times x? Now these aren't the same, right? 6 and x, there are two different bases. But we could rewrite these 6's as what exponent? We could write that as 6 to the power of 4, right? Now 6 is the base, right? It's easy to get the bases confused with the power sometimes. And what about these x's? Can we simplify these x's? Yeah, sure. We can simplify that as x is our base to the power of 3. I need to stop switching these colors around. Okay, so we could rewrite this. I know it's not maybe a single exponent, but we rewrote this part as a single exponent and this part as a single exponent. So we can simplify this whole thing as 6 to the power 4 times x to the power of 3. Okay, now here's what we're going to do. We're going to try to simplify these expressions. They're not just like we simplified these up here. And how are we going to do it? We're going to expand it out, write it out first, and then simplify whatever we get. Okay? So let's try to expand it first. Expand, then simplify. Okay? So let's see. X to the power of 2 means x times x, right? And then we've got another times here. So times x to the power of 4. That's x times x times x times x, 4 times, right? Oh, and then times another x. By the way, real quick, what is this power? There's actually a power here, right? This final x is x to the power of what? It's not 0. It's actually 1, right? We added 1x at the end. This is actually, if there's no exponent there, you can think of it as a power of 1. And then we've expanded it. Now can we simplify all of this? Well, yeah. Let's see. How many x's do we have here? We've got 1, 2, 3, 4, 5, 6, 7. We've got 7 x's. So we've got x to the power of 7. And that's our final answer. Now this is kind of important. This is the first exponent property or rule or shortcut that we can take. Notice how did we get 7 out of all of this, right? After we expanded it out, we basically wrote out how many different x's each of these powers gave us, and then we just added them up. So 7 actually came out of adding the powers from here. We simply added the powers. Right? We said here's 2, here's another 4, here's another 1, and then when we simplified, we just counted up how many there were. We added them together. And if you can look at here, 2 plus 4 plus 1 makes 7. So this was the same as, you could think of the shortcut here as x to the 2 plus 4 plus 1. Like I said, add the powers. And that's how we get our simplified answer of x to the 7th. And this is our first property. Maybe I'll box this up. Whenever we have the same base to a bunch of multiplied, this is sometimes called the multiplication of exponents, or the multiplication rule. You could think of it as, because we're just multiplying these exponents together, and you just add the powers. How about over here? Let's not take too long over here. Okay, so 6y(z) to the 2 raised to the power of 3. Let's expand it first, then simplify it. what do we get? Let me separate this, move this up a little bit. Well, 6 times y times z to the 2. Let me write that out. 6 times y times, and I'll even expand out the z to the 2. That's z times z, right? And then this power of 3 here means that we're going to rewrite it. We're going to multiply it by itself 3 times, right? So on top of that, we're going to have another times 6 times y times z times, I can make this a little bit smaller. 1 second. 1 second here. I want to try to fit all this in if I can. Okay, let me try this again. 6 times y times z, and then I'm going to, that's all raised to the power of 3, which means I'm going to multiply it. I'm going to write it again 3 times. 6 times y times z times 6 times y times z. All right, there we go. I've expanded it all out. Now let's try to bring it back together. Well, here's the wonderful thing about multiplication. It doesn't matter what order things go in. Think about the numbers. Think about it. If I said, what's 2 times 4, that's 8, right? And so is 4 times 2. That's also 8. It doesn't matter what order these come in. So it doesn't matter. All of this is multiplication. It doesn't matter what order they're in. So let's look at our 6's. How many 6's? Let's rearrange, kind of reorder things. We've got a 6 times a 6 times a 6. No evil anything there. What about our y's? We've got a y times y times y. Okay, we've got y times y times y. Times, how about a z's? How many z's are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I've expanded this out, and then I've rearranged the order so that the bases are next to each other, similar bases. Okay, let's see. How could we rewrite this? This is 6 to the power of what? It's 6 to the power of 3, right? There's 3 of them. How about y's? How many y's are there? We've got y to the power of 1, 2, 3, right? And then z, how many z's are there? We said there were 1, 2, 3, 4, 5, 6. There were 6 z's. Six z's. So, is there a shortcut to this? Is there an easier way we could have done this? And in fact, there is. If you look here, sometimes I like to call this rule, this is going to be called the power rule. So if you have a bunch of stuff raised to a power, the 6 got the power of 3, this got the power of 3, the y got the power of 3, and the z to the 2 also got a power of 3. See, 6 to the 3, y to the 3, z to the power of 6. So this is interesting. What happens when we have a power raised to another power? We multiply these powers. So there's kind of two rules in here, actually. One is called the everything gets that power rule. Let me kind of bring this back up here. Or maybe I'll say everything inside the parentheses, inside here. Is that kind of confusing? Let me see. Just write some dots. Everything inside the parentheses gets the power. This is called the power rule. So that's our second rule. Everything in here got that power of 3. 6 got the power of 3, y got the power of 3, and then z to the 2 also got a power of 3. And this is another kind of part of this, is that a power to another power, we multiply the powers. I'll do another example of that down below. But we multiply the powers here. Trying to do the best I can with this. All right.